Welcome to RN tutorials on mechanics of fluids, and in this video lecture I am going to explain about what is fluid kinematics and what are the different types of flows of the fluid that are going to take place. So first I would like to give the definition for fluid kinematics. So here the kinematics is fluid kinematics is a branch of science that deals with the motion of fluid without considering the forces causing the motion. Okay, this is the basic definition taken from the kinematics. So it is the study of motion characteristics without considering the forces which cause the motion. So in the same way here we are going to study about the motion characteristics of the fluid flow without considering the forces. So what are the properties or characteristics we can consider for motion? Means we know already that they are displacement, velocity and acceleration. So here also we are going to study about how to find out the velocity, acceleration with the help of the displacement of the fluid that we are going to discuss here. And next we have to know what are the types of fluid flow. So whenever the fluid displacement is taking place, that means when the fluid is moving from one place to another place, what are the different types of flows can take place that we have to know. First one is steady and unsteady flow, and second one is uniform and non-uniform flow, and third one is laminar and turbulent flow, and fourth one is rotational and irrotational, and fifth one is 1, 2 and 3 dimensional flow. Okay, these are the main types of the fluid flow that takes place during the movement of the fluid from one place to another place. So next we see the definition for each type of fluid flow. First one, steady and unsteady flow. So what do you mean by here steady flow and unsteady flow? We have to know. So first, steady flow. If what is the definition we can give means here, if the characteristics of fluid such as velocity, density, pressure, etc. do not vary with respect to time, then the flow is called as steady flow. Okay, so here with respect to the time, the properties of the motion or properties of the fluid should not be varying. So when the properties becomes constant with respect to time, then that flow can be called as here steady flow. So it can be mathematically represented as dv by dt is equal to 0. Okay, so if the property is constant, that is the velocity we are considering here, if the velocity is constant through the fluid field at each and every point in the flow field, then the differentiation of velocity with respect to time can become equal to 0, because we already know the differentiation of constant term is equal to 0 only. So that is why mathematically we can represent as dv by dt is equal to 0. So when this condition is satisfied, we can say that the flow is steady flow. And similarly, whenever you consider uh, sorry, here I'm taking one example, that is water is flowing, assume here, and in this flow field I'm considering 2 points, and I'm assuming at first point the velocity as v1 and second point velocity as v2. So when the difference is 0 in between these two velocities, then we can say that the flow is steady flow. That means when it becomes 0, the difference between these two velocities is when the both are equal. Both are equal means the velocity constancy it is maintaining. So then we can say that the flow is steady flow. Similarly, we can represent the steady flow mathematically with the help of another property, that is d rho by dt is equal to 0. And similarly, if you consider the pressure also, that pressure we can represent dp by dt is equal to 0. So mathematically we can represent with the help of the properties of the fluid to know about the steady flow. And similarly, unsteady flow. What do you mean by unsteady flow? So opposite to the steady flow, it becomes unsteady. So the definition again we can give, if characteristics of fluid such as velocity, density, pressure, etc. vary with respect to time, then the flow is called as unsteady flow. Here the properties should be varying. So when the properties vary from point to point in the flow field, then that flow can be called as here unsteady flow. So mathematically we can represent them as dv by dt does not be equal to 0. Similarly, d rho by dt does not equal to 0, and similarly dp by dt does not equal to 0. So it is not equal to 0 means the velocity is not constant. The velocity value is going to vary, and the density value going to vary, and the pressure value is also going to vary from point to point in the flow field. So when this condition happens, the flow can be called as unsteady flow. Okay, so that is about steady and unsteady flow. And next we go for uniform and non-uniform flow. So first we try to discuss about uniform flow. So let us have a look at the definition. So what is the definition here? If the velocity of fluid does not vary with respect to space at any given time, then the flow is said to be uniform flow. So here at any given particular time, we are considering the variation of velocity with respect to the space. Space means up to a particular length we will be considering the flow field. So with respect to that length, if the velocity is maintained as a constant at any given particular time of interval, then that flow can be called as a uniform flow. So that can be represented as dv by ds at any particular time, that is of 5 seconds, 2 seconds or 1 second. That should be equal to 0. So when this condition happens, the flow is uniform flow. So again, let us have a look at the diagram to understand thoroughly about it. So in this flow field, I'm considering a particular space of length s. So this space I'm considering in between the time 0 to maybe 10 seconds. Okay, so in between 0 to 10 seconds, this is the space I'm considering in the flow field. So with respect to this space, if you consider any 2 points in the flow field, okay, the variation between these two velocity values with respect to space, that should be equal to 0. So when this condition happens, again up to this particular length, if these two velocities are maintained as same values, then the uh, variation will be becoming 0. That means there will be no variation in the velocity. So with respect to the space we are considering, so in that condition we can say that the flow is uniform flow. Whenever you consider a particular length, a particular space of a particular length here, in that condition, if the property, that is the velocity, is maintained as constant, then the flow is said to be uniform flow. Okay, and next, what do you mean by non-uniform flow? Opposite to that again. If the velocity of fluid vary with respect to space at any given time, then the flow is said to be uniform flow. Sorry, non-uniform flow here. We need to write here non-uniform flow. So when the velocity varies from point to point with respect to whatever the space we are considering within the flow field, then that type of flow can be called as here non-uniform flow. Okay, next we go for next example, laminar and turbulent flow. So what do you mean by laminar? First, we need to know laminar flow. So the definition is, if fluid or fluid particles move in a well-defined path or layers or laminars, then the flow is said to be laminar flow. Okay, laminars means layers only. A layer means a particular defined path the particles will be following. So here, whenever the particles move in a particular defined path, then that flow can be called as a laminar flow. So if you see the diagram, you can easily understand. Okay, so this is the example diagram I have taken. Within the pipe, the water is flowing, and the direction, these are the lines represents along which the fluid particles are moving. Okay, so how the path is defined? The path is straight and each and every path is parallel to each other. When this kind of the flow happens, that type of flow is called as here laminar flow. All the particles should be moving in a well defined path, and that path should be parallel to the adjacent path of another fluid particles here. So next we go for turbulent flow. What do you mean by turbulent flow? If fluid or fluid particles move in zigzag manner, then the flow is called as turbulent flow, opposite to the laminar flow. Here the particles are moving in a particular path, but in turbulent flow, the particles will not be following any particular path. So randomly, the particles movement will be happening during the flow of the fluid. In that case, the flow can be called as turbulent flow. So diagrammatically, we can represent like this. Okay, so the particles will be following different paths, and there will be no parallelism between the two paths of uh, number of fluid particles are following, and again randomly the movement of the fluid particles takes place within the flow field. So this kind of the flow can be called as your turbulent flow. Okay, that is about laminar and turbulent flow. And next we go for next type of flow, that is the rotational and irrotational flow. So what do you mean by rotational and irrotational flow? So a simple definition that you have to remember here. During the flow of the fluid, if the fluid particles rotate about their own axis, then the flow is said to be rotational flow. So that means during the flow of the fluid particles, the particles will be moving from one place to another place. Not only moving, if the particles are rotating about their own axis, then that kind of the flow can be called as a rotational flow. And similarly, irrotational flow. What do you mean by irrotational flow? Means if the particles do not rotate about their own axis during the flow of the fluid, then the flow is called as irrotational flow. Okay, the simple definition, which is with reference to the rotation of the fluid particles about their own axis. Okay, if the fluid particles are rotating about their own axis during the flow, then the flow is called as rotational. If the fluid particles are not rotating about their own axis during the flow, means it is a irrotational. It is an irrotational flow. Okay, that is about rotational and irrotational flow. And next we go for fifth type: one dimensional, two dimensional, and three dimensional flow. Okay, according to the flow is going to take place in 1D, 2D, and 3D, we can define the we can classify the type of the flow also. So with reference to the velocity direction, again we can define the 1, 2, and 3 dimensional flow here. So first we try to discuss about one dimensional flow. So what do you mean by one dimensional flow here exactly? Means if the velocity of flow is a function of one displacement coordinate and time, then the flow is called one dimensional flow. Okay, one displacement coordinate and time. Velocity is a function of one displacement coordinate and time. Velocity always we consider under a particular time the displacement of the fluid particles. Here the velocity is going to take place only in one direction during the flow of the fluid, then the flow is called as a one dimensional flow. That is only a function of one displacement coordinate. So one displacement coordinate means the velocity will be in only one direction only. So how can we represent, sorry, and then so one displacement coordinate. So next it means what here? It means the flow will have velocity in x direction and velocities in y and z direction are zero. Okay, so one displacement coordinate means velocity, it can have the velocity only in x direction, and the velocities in y and z direction will be zero only. So that is the one dimensional flow. So with help of diagram also we can understand. If you consider a small diameter pipe, okay, and the flow is happening in x direction, so it can have the velocity in x direction only. So we can assume that velocity is a function of one displacement coordinate f of x, and velocity in y direction and can be assumed to be zero, because the what is the, if the here the diameter is very small, so we can neglect the velocity in y direction. In the similar way, the velocity in z direction also can be neglected, then it becomes w is equal to 0. So when one dimensional flow means we can neglect the velocity in y direction and velocity in z direction. Okay, so it can have only the velocity in x direction only. So in that case we can call the type of flow as one dimensional flow. Okay, similarly we can define the two dimensional flow also. So how can you define the two dimensional flow? Means if the velocity of flow is a function of two displacement coordinates and a time, then the flow is called as two dimensional flow. Two displacement coordinates means the velocity is going to take place in two directions, that is in x and y. Okay, and what about the third direction? Means the velocity in z direction becomes equal to 0. Okay, that is only I have written here. That is velocity, it can have the velocity in x and y direction, and the velocity in z direction is 0. So again, if you consider one example here, I'm considering this is the rectangular shape of flow field I'm considering, which is of width is very small. Okay, so in this condition it can have the velocity in x direction, which is the function of x and y. Okay, and it can have the velocity in y direction because the depth I have given for the flow field is more. So in that condition we cannot neglect the velocity in y direction. So the velocity in y direction also it can have. So that is why we need to consider two displacement coordinates whenever you consider the velocity. So that is why u is a function of two coordinates and v is also function of two coordinates. When you come to the third direction, which is the z direction, I have assumed the width is very small. So in that case the velocity in z direction we can assume it to be 0. Okay, so in this example the velocity in z direction is becoming is equal to 0. So it is having only two velocities in two directions, x and y. So this kind of the flow can be called as your two-dimensional flow. Similarly, three-dimensional flow. So same definition in the same way we can give, with the velocity is a function of three displacement coordinates and time, then the flow is called as three-dimensional flow. And it means the flow will have the velocity in x, y and z direction, all three directions the velocity is going to have for the flow of the fluid. So example, I'm considering again a flow field with a shape of some square I'm considering, which is of larger size. In this condition we cannot neglect the velocity in z direction or y direction or x direction also. So in x direction it can have the velocity which is the function of three displacement coordinates, because it is going to have the velocity in three directions, that is in 3D space. So we need to consider three coordinates for each and every velocity. So in the same way, the velocity in y direction also is a function of x and yz, and velocity in z direction is also a function of x and yz. Okay, so this is the two-dimensional, sorry, one, two, and three-dimensional flow. Based upon the flow size is going to take place during the flow of the fluid, we can classify different types of the flow also. Okay, these are the main types of flow we have to know. Okay.